Hello all, let's start section 2.4. 2.4 we discuss more on inequalities. What more on inequalities? Actually, in this section we cover inequalities that they are not linear. They can be quadratic, cubed, or they can be rational polynomials, correct? We cover in this section those type of inequalities. How to solve those inequalities and how to find the solution set for those inequalities. For example, let me show you. If they give me x squared minus 4x plus 3 less than 0, how to solve this inequality and find the solution set. That's our goal, correct? Few notes that I want to put here for you. Let's talk first about the steps, how to deal. In step 1, rewrite your inequality so that the polynomial is on the left hand side and 0 is on the right hand side and 0 is on the right hand side. Correct? What does it mean? Let me put an example, a quick example here for you. For example, if I have x squared, let's say minus 4x less than negative 3. If you see such a polynomial that you have terms on two sides of inequality, left hand side and right hand side of your inequality, rewrite your inequality how to put the polynomial on the left hand side and change the right hand side to 0. To do that, you already know that you can move the numbers, right? Here you have to add 3 to both sides and you can rewrite your inequality as a x squared minus 4x plus 3 less than 0. Correct? Because these two cancels out. That's your first step. You have to do this step, correct? Because if you have a number on the other side, then it's difficult to deal with and you will do a mistake. Step 2. In step 2, find the key numbers. Here in this book, we call it key numbers, but as soon as you move to calculus class, we call it their critical numbers or key numbers, correct? Find the key numbers for the inequality and locate them on the number line. This is your step 2. What is now key number? Let's answer to this question. What is key numbers? Because I have to know what is key numbers. If I don't know what is key numbers, then how to find them, right? Look at this 4 example here. For example, let's say P, capital P, and Q are representing two polynomials, correct? They are two polynomials. If I have P over Q, I have 4 cases. Less than 0, P over Q. Greater than 0, P over Q. Less than equal 0, P over Q. Greater equal 0. 4 cases. How to find the key numbers, or what are the key numbers? The key numbers are P equals 0 and Q equals 0. It means if I give you a polynomial, for example, in previous example, when I have x squared minus 4x plus 3 less than 0, to find the key numbers, this is a polynomial. You can name it P, right? Only one. I don't have a rational one, but here I have a polynomial. To find the key numbers, you set your polynomial equal to 0. That's the meaning. Put P equal to 0. Now, how to solve this? Of course, most of them you can factor, correct? -1, -3. And from here, x minus 1 equals 0, x equal 1. Here, x minus 3 equals 0, x equal 3. 1 and 3, we call these two key numbers. Correct? Key numbers. Look, as I'm going on with the steps to explain the steps for you, also I explain how to deal. Then later after this, I'll do 2-3 examples and I'll apply all the steps in it. And after that, you will see that you can find easily the solution set. Step 3. In step 3, list the intervals determined by the key number. List the intervals determined by the key numbers. Step 5. Or let me make it easier for you. I'll go different way. Step 4. Make a sign table. In your book, they made a table for you, but it's really confusing. I will do now examples for you, and I'll show you a different table which is really easy to understand. And also, if you can create such a table, immediately you can answer or you can find the solution sets for any given inequality, correct? Let's start with few examples. Let me finish first the one that we already started. x squared minus 4x plus 3. I think it was less than 0, correct? Step 1, bring everything to the left, make the right side 0. We already have that one. Step 2, find the key numbers, correct? To do that, we set our polynomial equal to 0. If we can factor, we factor. If not, definitely the quadratic formula, if it's a quadratic, correct? But usually you can factor them. Possible factors of 3 is 3 and 1, correct? Both of them should be negative to gives you plus 3 and negative 4. Now set each parenthesis equal to 0. X minus 3 equals 0. It means x equal 3. X minus 1 equal to 0. It means x equal 1. In step 2, I told you to make a number line. For this problem, I'll make a number line, but I'll show you actually your table contains of number line. But for this one, I'll make a number line for you to show the intervals, to explain what is intervals. After you find your key numbers, correct, mark them on number line. Of course, here 1 and here is 3. Now, if you look at to this number line, it's not a class that I can ask you a question. I'm asking how many intervals you can see on this number line. The answer is 3 intervals. What are those intervals? The first one starts from negative infinity to where? To 1. It's one of the intervals, you see? We call this part 1 interval. The other interval starts from 1 to 3. And the third interval starts from 3 to infinity. You see? You have 3 intervals. In your book, they say, oh, pick up a test point now from each interval, plug it to your inequality, and make a sign chart. But let me show you something easy. Make a table. How? A very easy table. I'll show it for you. How many key points we have? 2 key points. I'll draw here 2 lines. 1, 2. Here I'll write 1, here 3. This is actually the top line is your number line. You see it? Correct? Here, of course, you have negative infinity. Here at the end, you have infinity. Do you see your intervals now here? Now, after you factored, which factors you had in your polynomial? You had x minus 1, one of the factors, and you had x minus 3, another factor. Write it down like this. At the end, write down your polynomial in factor form, which was x minus 1 times what? X minus 3. Less than 0, correct? It was less than 0. Now, look. Key numbers means graphically, if I explain it to you by geometry, key numbers, most of you, you know, when you are dealing with a polynomial and you make it equal to 0, actually you are finding the zeros of your polynomial, or I can say the x-intercept of your polynomial, correct? Key numbers are the x-intercept of polynomials. Correct? Remember this. Key number is the x-intercept. Okay. X minus 1. At what point x minus 1 becomes 0? When x is equal to what? To 1. Draw a 0 on 1. At x minus 1, when it becomes 0, if you plug in x, you see x equal 1. Do you see here? When x is 1, this x minus 1 becomes 0. X minus 3 becomes 0 at 3. Do you see it here? X minus 3 becomes 0 when x is what? 3. Now, sign chart gets really easy. In your book, they tell you, oh, plug in a number less than 1 in your polynomial and see what is the sign of your polynomial. Plug in a number from this interval, plug in a number from this interval. But if you can see the 0 here, which kind of numbers are on the left side of the 0? Of course, negative number. Which kind of numbers are on the right side of 0? Of course, what? Positive numbers. Here negative, negative, here positive. Here you have a product. It means multiply these. Negative times negative, correct? Let me show you. Negative, you multiply this way and you write the answer here. Negative times negative gives you positive. Here, positive times negative gives you negative. Positive times positive gives you positive. What the inequality says, less than 0. Which type of numbers are less than 0? Of course, negative numbers, not positive numbers. Then the solution set is here. You see how easy is that? How easy you can find? This part will be your solution set. What is this interval? From where? From 1 to 3. Your solution set is 1, comma what? 3. It means any number that you plug in between 1 and 3, for example 2, this inequality, the left side will be less than the right side. Correct? Let me do another example for you. Example 2. Let me copy this example from your book. X cubed minus 2x squared minus 3x greater than 0. Correct? Find the key numbers. Set this polynomial equal to 0. X cubed minus 2x squared minus 3x equal to 0. Can we factor? Yes, definitely. First GCF, because you see x is everywhere. Then what left inside? X squared minus 2x minus 3 equals 0. Can we factor again this part? Definitely yes. It will be 2 parentheses, x and x. Correct? Possible factors of 3 is 3 and 1. Correct? To get negative 2, negative 3, positive 1 equal to 0. Now set each of these parentheses equal to 0, including x. X equals 0, one of the critical numbers, no, I'm sorry, not critical numbers, key numbers. X minus 3 equals 0, it means x equals 3. The second key number, x plus 1 equals 0, it means x equals negative 1, the third key numbers. Correct? Now, draw your sign chart or sign table. That's the easiest way. You don't want to draw a number line, then again a table, then plug in numbers. It takes a lot of time. Why not the easy way? How many key points I have? Or key numbers? 3 of them, right? 1, 2, 3. But focus, it's a number line. You have to put them in order. Here, negative 1, then 0, then 3. Correct? Write the factors in this column. The first one was x, the other one was x plus 1, the other one was x minus 3, and in the last, the polynomial x times x plus 1, the product of all these three. X minus 3 greater than what? I think this problem was greater, right? Greater than 0. Let me separate this. One row, two row, and three rows. Of course, here you have infinity, and on this side here you have negative infinity. At what number x becomes 0? Of course, at 0, x becomes 0. What is on the left side of 0? Which kind of sign I should put on the left side of 0? Of course, negative numbers are on the left side of 0, and positive numbers are on the right side of 0. X plus 1. At what number x plus 1 becomes 0? Of course, here you can see you already did it. At negative 1. Left negative, right positive. And at what number x minus 3 becomes 0? Of course, it's 3. Left negative, right positive. This table avoids test points. Correct? That's why it's an easy way to deal with. Now, multiply all the signs, column by column. Negative times negative times negative gives you negative. Negative times negative gives you positive. Positive times negative gives you negative, and here positive. Now look at your inequality. Is this greater than 0? Greater than 0 means positive numbers, right? When it's positive, then shade the columns that you have positive sign. Now, write the interval. Write your solution set in interval notation. From negative 1 to 0, and here from 3 to infinity, right? To connect these two, I need the sign of union. This was all about dealing with polynomial inequalities, correct? I'll stop it here. In next video, I'll explain for you the inequalities that they are the quotient of polynomials, or we call them rational inequalities, correct? I'll stop here and see you all in part 2 of section 2.4.